So a basic sum that really fucked my mind was where I needed to find the number of onto functions given in two sets. So let's say the question was, I need to find onto functions from A to B. Alright, and what were the values for A and B? Let me just quickly check. So A was 4 and B was 3, correct. So the whole crux of this question is to understand what the fuck are these onto functions. They are very irritating for sure, but they are fun if we just give them some time and a lot of our mental energy, which I did, so you don't have to. Allow me to explain. Onto functions, let me just make this P, Q, R, S, and then there is another set with 3 elements, say 1, 2, 3. Now, an onto function by definition says that all the elements of set B should be assigned to the elements from set A. Alright, pretty basic, but wait, it gets more fucked. How do we find the number of combinations that are possible? It's humanly impossible, but I think mathematicians feel perhaps the students can do a fairly decent job. Never mind, that's a debate for another day. So how do we essentially find out? So getting back to the example, a basic definition of an onto set would be, if I'm assigning P to 1, I'm assigning Q to 1, I'm assigning R to 2, and S to 3. Now we need to do it we need to find all those possible combinations that exist. So to do that, we have to subtract all the cases that do not make it an onto. How do we do that? Pretty simple. So if you have to find the number, it would be something minus the total number of functions that are possible. And upon quick reference to my own notes, which I have forgotten, the total number of combinations of functions are possible, 3 power 4. I'm just going to switch into another color. 3 power 4, which is equal to 81. From 81, we have to subtract functions that are not onto. Straightforward, right? What makes a function not onto? You may have that doubt. So a function becomes not onto when you have cases like all the functions are assigned to only one member of B, that is, okay, and this to this. So this is unassigned, which cannot be an onto. Okay, so this is one case, and the other case could be only 2 elements are used, which could be something like, or R goes to 2. What this means is we do not want these cases, which in terms of mathematical stuff becomes 1 minus exactly 1 plus exactly 2. Fine, okay, straightforward. Actually straightforward. No, not sarcastic. If you see this case over here, how many possible combinations are there? Now just notice that there are 4 elements in A, there are 3 elements in B, which is exactly the problem in our life and currently. So there are 3 cases possible. Okay, everything to 1, everything to 2, everything to 3. So that becomes 81 minus, okay, exactly 1 becomes 3. Just going to use this Okay. Now, exactly 2. How do we know what makes exactly 2? Well, here it is. We consider that we need there are only 2 elements in B. Okay, so temporarily just assume this is like this. And if we had to find exactly 2, what would that be? Right? So that would be the total number of possible functions minus all the functions that are either exactly 1, or using another color here, or exactly. Okay, so there are 2 cases of this, right? Out of the possible cases, 2 power 4, which is equal to 16. Thus this becomes 2 power 4 minus 2. Now in our case we have another little dude hiding, and we need to do it for all of the possible combinations. Now what are the possible combinations? So you'll say that okay, first we did it for 1 and 2, then we'll do it for 1 and 3, then we'll do it for 2 and 3. So 3 of them, so 3 times. So this then becomes 3. I think not the best use of brackets. Okay, using this to say okay, whatever. And when we simplify this, we are left with 81 minus 3 plus 42, which is equal to 36, which is what my AI thinks as well. God knows how. But my understanding says that there are 36 such functions. Okay, I don't think this is exactly the number of functions, it's the set of functions, okay, or combinations that are possible. So I want to take it one step further and demonstrate it for many who would be wondering what the hell is this. So, and I'm just going to illustrate one ideal onto set QRS. Then you have 1, 2, 3. An ideal onto set would look something like this. Okay, and we need to find how many such sets exist. So thinking on another level, if I'm saying that in this set, what do I have? Okay, so we have P and Q being assigned to 1. Similarly, we have Q and R assigned to 1. We have RS assigned to 1, and so on. So let me quickly populate it for you. Now here, if you see, each one of this is assigned 2 functions. So 2 each. Okay, and if we consider this example above, which is P and Q are assigned to 1, you are left with R raised to 2 and S raised to 3. Alright, this will make PQ assigned, this will make one combination. Okay, similarly there are going to be various combinations, and presuming that my last combination will look something like this, so it will be SQ to 3. Alright, where S and Q are already assigned to 3, so I can say okay, P1 and R can go to 2, and this is going to be another set of functions. So there are going to be 36 like these, which ensure that at a time all the elements of set B have assignments from set A. So I'm just going to quickly draw this. So P, Q, let me use a different color, P, Q, R, S, 1, 2, 3, just for example. Give it a little more aesthetic vibe. Should work. Awesome. Okay, then I'm going to use blue. So here I'm going to have R going to 2, then I have P going to 1. I don't like wavy lines. Okay, then we have S going to 3, and then we have Q going to 3. This is how it's going to look, and the whole problem states the same thing. What we've been able to, derive on top. There are 36 such combinations that are possible, wherein we get an onto function. What is an onto function? Something wherein all the elements of the set B have assignments from set A. Hope this saved the time and effort that you would have put in to figure this part of the video. Credit to Ravi from Roda for helping me out throughout and inspiring this explanation. So thank you to you too.